Okay. Uh, Good morning, students. Today we are going to cover the acoustic emission sensor topic. Basically, acoustic emission is nothing but the emission of elastic wave or acoustic wave. Uh, you might be learning about this type of waves in your gas dynamics section. Okay. So acoustic emission is all we are using AES, the short form for acoustic emission. Acoustic emission is the phenomena of radiation of acoustic waves. That is just an elastic wave. Okay, elastic type of wave in solids that occur when a material undergo irreversible change in internal structure. That is, acoustic emission waves. We are discussing about the acoustic emission sensor, nothing but used for sensing some physical parameter with the help of acoustic waves. Okay, here acoustic waves are used for sensing some physical parameters. Okay, so here the acoustic emission is the phenomena of radiation of acoustic waves in solids. Usually solids emit acoustic wave at a certain conditions. Okay, that occurs when a material undergo a irreversible change in its internal structure. um, I think you can simply understand what is the change in irreversible change in internal structure. It is nothing but a permanent deformation of the structure of a solid. That is, imagine we already, for example, we are talking about a just a specimen of a steel rod. So, if you think it undergo an irreversible change in its internal structure, you can see that uh, there might be some internal crack or internal just flows inside the steel bar that we are already taken. So during that, during when a solid undergoes a irreversible change in internal structure, the solid will emit some type of radiation. It is called acoustic waves. Okay, during the permanent internal structural change of a solid. Okay, you have to keep in mind that it is the irreversible change in internal structure of a solid. Okay, when this change is taking place, that solid will emit a certain type of radiation called acoustic waves or elastic waves. Okay, both are same, acoustic waves or elastic waves. So I think the basic what actually that happening there is some sort of waves is emitted by a solid material. Okay, so for example, as a result of crack formation or a plastic deformation due to aging, temperature gradient or external mechanical force. That is, for example, if we are not giving an external force to that particular solid, we already taken a steel rod as a solid. So if we are not actually giving an external force, there is a chance for automatically uh, irreversible change to occur. Okay, that is through aging or due to temperature gradient, due to change in atmospheric temperature. Okay, or due to external mechanical forces. Okay, so there is an automatic chance for material to change its internal structure. Okay, I think there is a chance automatically to emit acoustic waves by steel rod specimen. Okay, so I think it is clear to you. So in particular, acoustic emission is occurring during the process of mechanical loading of materials and structures accompanied by structural changes that generate local source of elastic waves. This is the practical case. We are actually using acoustic emission sensors. Okay, Hello? Hello, hello.
Yes, sir.
Okay, okay, okay. It was a network problem. So I'm continuing from here. From here. Okay, solid material. You can see an external force or stress is applied on this material. Then you can see some type of elastic or acoustic emission wave is emitted by this material. Okay. This acoustic emission wave that is emitted by this material is sensed with the help of an acoustic emission sensor at the top. Okay. By keeping an acoustic emission sensor at the top, and if a material emits this type of acoustic emission wave, that wave will be sensed by the sensor, and then the signal is fed into an acoustic emission detection instrument. Okay. Thereby, we can record how much intensity of crack or those things are actually occurring in that solid. Okay, this is the basic experiment setup or measurement setup for an acoustic emission sensors. Okay, this is the working, how it is working. So you can see that at the detection stage, the material is given a certain type of loading, and due to permanent internal structural change that is represented with a orange mark, due to internal structural change, only when internal structural change occurs, the acoustic emission wave will be emitted by these types of sensors, and the sensor take this signal, that is acoustic emission signal, and it is given into a pre-amplifier. The role of amplifier is to amplify, just to increase the strength of signal. You can see here at the detection stage, it is very small, it was very small, the signal strength is very small. After the pre-amplification stage, you can see a very big size signal, okay, compared to the initial signal. Okay, so after the amplification stage, it is given into a acquisition and a storage. Acquisition is nothing but a data analysis system. Okay, the data of this elastic wave is analyzed with the help of this acquisition system, data acquisition system, and it is stored here. And at the fourth stage, that that reading, actually nothing but a plot, is displayed. Okay, this is the basic working of a acoustic emission sensor. So you have to understand that acoustic emission sensors are used in a wide range of field, including the inspection of manufactured products, monitoring the safety of structures, and development of a new material. At these stages, the acoustic emission sensors are have application. Okay, so acoustic emission is the sound emitted as an elastic wave by a solid when it is deformed. Okay, the use of acoustic emission sensor is to detect these elastic waves and to non-destructively test on material is called the acoustic emission method. That is, with the help of this method, that is acoustic emission sensing method, actually the specimen is not destructed. We are not breaking the specimen and testing. We are nothing doing with the specimen, but we are just placing a sensor above the specimen and getting the result without destructing the specimen. That is why it is called a non-destructive testing. Okay. So quite some time before failure occurs, tiny deformation and minute crack will appear and spread in the material. You already know we are giving a force to the solid, but before failure occurs, the tiny deformation and minute crack will appear and spread in the material. This is the idea. This is the situation where we have to use our acoustic emission sensor. You have to use it before the failure occurs, okay, of the material. So by picking up the trends in acoustic emission, the acoustic emission method can detect and predict flows and failures in materials and structures. Okay. So these are the other type of non-destructive testing methods. The ultrasonic testing, radiograph testing, eddy current testing, acoustic emission testing. These are all examples of non-destructive testing method. Okay. Here the ultrasonic testing is somewhat similar to that of acoustic emission sensors. Okay, you have to keep in mind that ultrasonic testing is very much similar to that of what acoustic emission sensors. So both are the same. You can simply take this diagram and instead of writing here the acoustic emission sensor, you can simply change it as a ultrasonic sensor. The difference I will explain in the here. Okay. So in case of ultrasonic sensors, in case of ultrasonic sensor, you can see that at the left part, I am actually representing a ultrasonic sensor or a transducer. In the right side, you are actually we are actually plotting a acoustic emission sensors. Okay. So you can see that in acoustic emission sensors, the wave is directly emitted by the material itself. You can see the direction of propagation of wave. Okay. If a flow is there, you can see that a wave is starting from the flow to the sensor or transducer. Okay. This is the working of an acoustic emission sensor that we are already discussing. When force is applied, the crack will form and it will emit a certain frequency wave. Okay, that is called acoustic emission wave. This is the working of acoustic emission sensor. But here in the left side, you can see that a transducer is placed, which is called a ultrasonic transducer. In this type of transducer, you can see that signal is given into the solid where the flow is actually situated, and then that signal is reaching the flow and it get reflected back into the sensor itself. Okay, so this type of sensor is called ultrasonic sensor. Okay, ultrasonic sensing is nothing but the sensor itself emit a certain wave called ultrasonic wave, and it reaches the same flow, and flow means crack or damage. Okay, so it reaches the flow and it is returned back into the sensing element itself. That is how, by calculating the time of reaching emitting and receiving the signal, we are actually finding the depth and nature of flow. Okay, so I think the ultrasonic sensor and acoustic emission sensing is clear to you. Nothing, the only difference is instead of using the acoustic emission sensor, we have to use ultrasonic sensor. You have to, if you are explaining about the acoustic emission sensor, this is actually occurring here. The wave, acoustic emission wave is emitted by the flow. And in case of ultrasonic sensors, the wave which is to be measured is emitting by the sensor and it is also received by the sensor. This is the difference. Okay. So I think the working of acoustic emission sensor and ultrasonic sensor is clear to you. You can use basic this thing. Okay, this figure as your basic idea. Okay. So I think it is clear to you. So these are the different types of acoustic emission sensors. One is a resonance model and the other is a wide bandwidth model. Okay, we already discussed about the application at the previous slide. Okay, it is used for manual inspection, monitoring the safety structure and development of the material. Okay, I think we can move on to this is the application used for detecting application setup. Okay, magnetic disk application for product testing, and used for electric motor detection of abnormal sound in electric motor testing. These are all the application situation of acoustic emission sensors or sensing method. Okay, so as far as our topic is concerned, only need to discuss up to that point. Okay, so coming into the vibration sensor, we have to discuss three types of vibration sensors here. So vibrations are nothing but measured to and from motion. We already discussed. Vibrations are measured by measuring the displacement, velocity, acceleration of a vibrating body with the help of vibrating measuring instruments. Okay, so the vibration measuring instruments having mass, spring, and dashboard, etc., is known as seismic instrument or seismic simply transducer. Okay. So the quantity of displacement, velocity, acceleration are measured and displayed in the form of electrical signals with the help of an amplifier. Okay. This is we are actually either measuring displacement or velocity or acceleration of that to and fro motion of vibrating system. Okay. With the help of vibrating sensors. So the output of the electrical signal is proportional to the quantity to be measured. That is, for a highly moving or high frequency system, the magnitude of electrical signal produced will be higher, and in a low frequency system, the magnitude of or strength of electric signal will be comparatively less. Okay, these are the three types of vibration measuring instruments. They are vibrometer, also called a seismometer, used for measuring displacement of the vibrating system. You have to identify this. Here, with the help of vibrometer, they are actually measuring the displacement of vibrating body. Okay. So in case of accelerometer, the name indicates itself that it measures vibration of acceleration. Okay. Next is laser Doppler vibration meter. Okay. These are the three types of vibration measuring instruments. So in case of seismometer, seismometer is designed with a low natural frequency, and hence it is known as low frequency transducer. Relative motion between the mass and vibration body is converted into proportional voltage, and it can be recorded. This is the basic working of a vibrometer or a seismometer. Okay. Okay. Next is accelerometer. We can take it in the next class.